everyone. So students, in the previous class we discussed about the Wheatstone's bridge. Yes. So what we discussed in that? We are comparing the resistances. Yes, in the Wheatstone's bridge. That means if you know the value of two resistance, then you can easily calculate the third and the fourth resistance. Yes, and in that we also mentioned the one condition, that is balanced condition. Yes, what is that? Making the galvanometer current will be zero. Nothing but the making galvanometer as a zero deflection. That is only we call it as balanced condition. That is nothing but the current through the galvanometer will be zero. Yes, Ig is equal to 0. Just remember. Yes, this is only we call it as balanced condition. Yes. So now the next part we are moving, that is the meter bridge. Yes, I think it is there for your practical exam also, and for the theory also they given that one. Then this is also the one important question for your exam purpose. Okay, take it as important. And here, what is this then meter bridge? See, meter bridge is nothing but it is also one instrument. Yes, here this meter bridge which mainly works on the principle of the Wheatstone's bridge. Yes, see, this meter bridge works on the principle of Wheatstone's bridge. Yes, so then see why we are using this one then, meter bridge. See, the Wheatstone's bridge we used to calculate the value of resistances, right? So now this meter bridge is also used for the measuring of an unknown resistance. See, basically in the meter bridge also we are using to calculate the unknown resistance. Yes. So first point, similar as like the Wheatstone's bridge, it is used to measure the unknown resistance. Yes, first point. Then second one, determining the resistivity of the material of the wire. See, first we discussed that we are using this one to calculate the unknown resistance. First point. Then second one is resistivity of the material that we used in the meter bridge. That is nothing but the wire. So first one we are calculating resistance. Second one is the resistivity. Yes. Then third one is comparing the two unknown resistances. Third one is comparing the two unknown resistance. That is also we can measure with the help of the meter bridge. Yes. So see, the Wheatstone's bridge we mainly used to calculate the unknown resistances, or else for the comparison we used. And similarly, the meter bridge is also used to calculate the unknown resistivity of the material, and third one is the comparison of the two resistance values. Understood? This is about the meter bridge. Yes. So students, here I will give you the one homework. Just you Google it. What do you mean by resistivity and what do you mean by resistance? Yes. Resistance and resistivity. Yes. And you also see on what things the resistivity will depends. Yes. See, basically you know that the resistivity will different for the different materials. Understood? So on what things this resistivity will depends? Maybe some cases are there, no? Some properties of the materials. On that this resistivity will depends. Then only we can see the resistivity of the aluminium will different, resistivity of the copper will different. Yes. So just you Google it. What do you mean by resistance? What do you mean by resistivity? And on what properties these two things will depend. Yes, that is the homework H. Yes, what it says? There is a comparison. It is a mathematical form that used to comparison the value of resistance. Yes, and the balancing condition where the current through the galvanometer will be maintained as 0. This one. That is the principle of the Piston's bridge. Yes, on that only this will works. Yes, so now we will see the construction or is the circuit diagram of this meter bridge. Take it as a circuit diagram. Circuit diagram. Yes, this is the circuit diagram of the meter bridge. Yes, so what it is then now? See, just here, this box you can see no at the bottom. This is one wooden box. What it is? Wooden box. ಒಂದು ಕಟ್ಟಿಗೆ ಪೆಟ್ಟಿಗೆ ಇರ್ತದೆ. Yes, on that we are stretching the wire. Yes, this is the wire. See, this is the wooden box, and on this the wire is stretching like this. Stretching means from A to C I am taking the wire. Just consider this is the wooden box. This is one point and this is one point. Yes, from here to here one wire I am taking. Yes, now on this wooden box one wire is stretching from the A to C. Yes, then after this you can take the length of the wire as is 1 meter. Yes, length of wire as 1 meter you take. Yes, so L, the wire length will be how much? 1 meter. Yes, so take it as this is the point A and this is the point C. Understood? So now in between the point A and C we are connecting the one battery here. Yes, battery, take it as a which is having the EMF E. Then one more key we are using. Yes, so battery and the key which are connected in between the point A and point C. Yes, so now this wire and we are connected again to the L-shaped strips. This is the one L-shaped strip and this is the another L-shaped strip. Yes, like this. This is the box. Yes, and again like this we are connecting that one. Yes, so here one point is there and here one point is there. So again we are using the one more strip in between this middle. Again one strip is there. Yes, that is having the two holes. Yes, 2 points that is having, and here one point and here one point it is having. Now this first L strip and this second wooden strip I am connecting in between one unknown resistance. Yes, so in between these 2 points I am connecting the unknown resistance. What I told? Unknown. Yes, we don't know the value of that resistor. So I told you unknown resistor. Yes, so again in this point and this point we are connecting the known resistor. That means standard resistance we are putting here. Yes, so I am telling you the connection here now. Just here the one wooden box is present. On that we are stretching the 1 meter length wire. Yes, so again this one I am connecting to the 2 L-shaped strips. Yes, and then in between that again one strip we are taking, and this first L strip and the second strip in between that I am connecting the one unknown resistor. This is the unknown resistor. You take it as R. Yes, and now in these 2 points I am connecting the standard resistor. What I told you? Standard resistor. Standard means already we know about the value of that resistor. Yes, so take it as yes. Correct? So now here you take the in the middle strip we are making the one point B, and from that I am connecting the galvanometer. Yes. So I am connecting to the galvanometer, and the other end of the galvanometer I am connecting to this wire. On that wire, one more point is there. You can take it as D point. D point. So B to D I am connecting the galvanometer. Correct? So this is about the construction of the meter bridge. Yes. So now what I will make, this galvanometer I will connect it to the sliding contact. See, just consider this is the galvanometer one end and it is a wire. So like this sliding contact I will make, and if it touches this one, I have to notice that the galvanometer must show the zero deflection. What? I have to know that the galvanometer must show the value of zero deflection, because we want to achieve the condition that is balanced condition. Here this one, yes, we want to achieve the balanced condition. That's why we have to make sure that the galvanometer, this point, this D point must touches to the wire, then it show the zero deflection. Correct? So like this we made the construction. So now what I will do, this is about the construction. So now how it works, see, here the standard resistance is there, right? So here unknown resistance is there, correct? So now what I will do, I want to calculate this unknown resistor. So what I will do, I will remove some resistor value from this standard box. Yes. So I will take the 10 ohm first. Yes. From this I am taking the 10 ohm. Here the first reading. 10 ohm I am taking. Yes. So I will remove the 10 ohm resistor, 10 ohm key from this resistor. So we already make sure that the galvanometer will touches the sliding contact of that wire. Correct? Like this it will touches. So when it touches that point, no, that time it must show the zero deflection. See, now it is here. When this wire touches here, it shows the zero deflection. Correct? So up to this point, the length I have to measure. Yes, already we know that it is the 1 meter length. Correct? So up to here, it is how much? 1 meter length. Right? So now see, only this much, this touches to this point. So I can take the value of this much length now for the 10 ohm resistance. Yes, take it as a how much? 0.5 you take. How much? Length in meter. How much we got here? 0.5. Correct? So this much only we got. How much it is? 0.5. Because at this point the galvanometer is showing the zero deflection on that wire. Correct? When I remove the 10 ohm resistance from this standard resistor, the galvanometer shows the zero deflection at this point. Correct? That is how much? 0.5 meter. Yes? 0.5 meter. That only I am written then. Correct? So, see, if this much we are calculating means, of course we have to calculate 1 minus L also. Correct? So, what will happen now? 1 minus L means 1 minus 0.5. How much we are getting? 0.5. Correct? Right? You will write the tabular column no, while doing the experiments. Same only I am doing here. And then these all the values put in that formula. How much? See, R is equal to 10 into L how much? 0.5 divided by 0.5. So it will get cancelled and what it becomes? 10 ohm. Right? So this is the working of the meter bridge. Yes. So here measure the distance from the point A, which is known as the balancing length L. So direction. Correct? So this L is there, no? From A to D we are measuring, that we called it as balancing length. What we call balancing length. Yes? So now we are calculating the unknown resistance by using the formula R. Yes? What is the formula? Yes. Yes means standard resistance. Take it as S is equal to standard resistance. Then L is the balancing length. Then R will be unknown resistance. Understood? So, by using this formula, we can easily calculate the unknown resistance. Okay? So, this is about the construction principle and the working of the meter bridge. Understood? In the next class, we will take the next part. Okay?